How can we factor quadratics whose leading coefficient is not equal to 1 without using guess and check? Well, we can use the AC method. And it's called the AC method because the general form of a quadratic is written like this: ax squared plus bx plus c. And so the AC method starts out by first multiplying the a term times the c term. So here we're going to be multiplying 7 times negative 4 to get negative 28. And once we do that, we're going to ask the question, okay, what factors of negative 28 add up to negative 12? Well, let's write down some factors of negative 28. We have negative 7 times 4. We have negative 4 times 7. We have negative 14 times 2. We have negative 2 times 14. We have negative 28 times 1. And we have negative 1 times 28. So which of these factors add up to negative 12? Well, check this out right here. Look at this. Negative 14 plus 2 is equal to negative 12. So now we're going to rewrite, once we do that, once we find factors of negative 28 that add up to 12, or in general, factors of a times c that add up to the b coefficient, well, they're going to rewrite the b coefficient using those factors. So in this case, we're going to rewrite negative 12 using 14. We're going to rewrite negative 12x using negative 14x and 2x. So here's what I mean. Look at this. Negative 12x is equal to negative 14x plus 2x. And so now we can rewrite this quadratic without changing it at all. We're not changing the value of this quadratic. We're just writing negative 12x in a different way. So this quadratic can be rewritten as 7x squared minus 14x plus 2x minus 4. Again, we're not changing the value of this quadratic. We're only changing how we're writing negative 12x, which does not change the value of this quadratic because negative 12x is equal to negative 14x plus 2x. Okay, so now once we write the b term like this, check out what we can do. We can factor this binomial and this binomial individually, independent from each other. So what I mean by that is if we wanted to factor this binomial just by itself, we could take out a 7 and an x. We could distribute out a 7 and an x to get 7x times x minus 2. And we can add that to, now we're going to factor this binomial individually. So we can say, we can take out a 2 here. And we can say that 2 times x minus 2, this is the same as 2x minus 4, right? This guy is the same as this guy. So, look at this. We have an x minus 2 over here, and we have an x minus 2 over here. Let's say that I rewrote, or I said that x minus 2 is equal to u. Let's say that x minus 2 is just equal to some variable u. So if I wanted to rewrite this guy, then this would turn into 7x times u plus 2 times u. And look at this. By the distributive law, each of these terms have a u in common, so I can distribute out the u to give me u times 7x plus 2. Well, u is just equal to x minus 2. U is just equal to x minus 2, so this can be rewritten as x minus 2, because remember, I just used u as a variable to represent x minus 2. So this guy can now be rewritten as x minus 2 times 7x plus 2. And look at this, we've just factored this quadratic right here without using guess and check. And this is a quadratic whose leading coefficient is not equal to 1.